everybody, and welcome. My name is Julie Noblet. I'm the Community Manager at the Diagram Center here at Benetech, and I'm delighted to welcome you to today's webinar entitled Accessible Images from Creation to End User. With us today, we have three fantastic speakers, Lucia Hasty from the Mountain Braille Associates, and then Bryan Gould and Geoff Freed, who are both from the WGDH National Center for Accessible Media. I just want to give you a very quick rundown on what to expect today. Our hour-long session, will be broken down into three main parts. Lucia Hasty will begin by giving you an overview of tactile graphics. We'll move then to Bryan Gould, who will give us a rundown on best practices for how to write image descriptions. And finally, Geoff Freed will conclude by showing us a very interesting demonstration of what the end user's experience is, trying to use images in an online format. We'll conclude about 10 minutes before the end of the hour to give us a chance to answer any questions you may have. All of you are muted. We won't be able to hear you, but please feel free to enter your questions in the chat box that should be in your ReadyTalk console. We will be collecting those questions, and then we'll answer them for you as we can at the end. And so with no further ado, I will turn it over to Lucia Hasty.
What a great turnout. It's just wonderful to have this many people wanting to know the answers. I apologize, first of all, for sort of a raspy voice today. I hope that I'll be understandable. I'm going to talk about tactile diagrams that are also called tactile graphics, or also called raised line drawings, lots of different names. Traditionally, you find them in Braille textbooks or in supplements to textbooks or as a standalone, like an atlas or a group of diagrams that are related to a particular kind of a subject. The production methods they're all pretty complicated for most producers, unless you have this very specific equipment. The production methods are collage and or tooling, which means you paste and glue things onto a master, and then you make a plastic copy of it. Microcapsule paper, which is also called swill paper or puff paper. Computer design and embossed, and that could be from several different computers, a Tiger embosser, a Phoenix embosser, or a standard embosser with low-resolution graphics. Or you may see some commercial productions, press braille, or rosin, ink, or powder deposit method. Producers of alternate media often get stuck at how to deal with all the images that accompany the text. There are really pretty much two questions. How do you produce these things? Do I have the capability to produce it? And how do I deliver this to the reader? As we look at more and more digital access to text materials, the problem of that delivery becomes even bigger. And so that's what the Diagram Project is all about, is to figure out a good way to do that for images to accompany Bookshare or Learning Ally kinds of digital textbooks. This may be comforting to know that in a recent in-depth analysis of two textbooks with more than 800 images among the two textbooks, it was determined that less than 10% of the images needed to be produced in the form of a tactile graphic. So you can sort of take a deep breath about that, because it's not nearly as big a task as it looks like it's going to be. Determining which ones are needed is the hardest part, I think, that most producers have. And one of the tricks to determining that is to use a decision tree. This decision tree is actually in the Braille Authority of North America Guidelines and Standards for Tactile Graphics, and I'll give you the reference for that. But I'm going to sort of break it down into an easier task. The first question you ask is this information a repeat of facts in the text? The second question, would the information be more meaningful in text form? The third question is, does the graphic require the reader to use visual discrimination or visual perception? If the answer is yes, you do not produce this as a tactile graphic. This is an example that has several problems along the way. Number one, it is, in fact, the text is there already. If you'll see the little numbered 1, 2, 3, 4 with little red circled numbers, that text is already there that explains exactly what happens when HIV enters the body. And so the image itself has no additional information. It has symbols that most Braille readers are not going to recognize. If I were going to describe this, I guess I'd be talking about pita chips and fried eggs and almonds and malted milk balls. I mean, these are peculiar symbols that really aren't related in any way to HIV. So this would be one that is definitely more meaningful in a text form than in a tactile graphic. This is another one. This is an example. This is from a psychology textbook. And the whole point was which of the three 2x4s, whatever they are, which one of those is the tallest. And that requires that you use visual perceptual skills. There is no comparable piece of that for Braille readers, so this is an image that is not going to be done as a tactile graphic, although the task would be described in a good description, which Bryan will definitely be explaining to you about that. When you do produce a graphic is when the actual object is unavailable to examine or touch, and that could be anything from an atom or a cell nucleus to something that's really, really huge, like the atmosphere. Does the reader need the information to participate in an activity, complete an assignment, or understand the concept? And I think that's probably the most important question of all of these questions is if you need to know what's in this image in order to do whatever it is you need to do with that textbook, then yes, it needs to be produced in some way. I'm sorry, I just lost my train of thought. This is an example of what needs to be a tactile graphic. This could be a description, but what would need to be for sure included in the description is where the lungs and the heart are located in the body. And if there is no explanation about where that is, then the reader is not going to know how all these parts are connected together. The same with an image of the digestive process or the nervous system. A lot of science graphics, where the parts are in relation to each other becomes a problem, becomes no information for most readers. As I mentioned, this decision tree is in the Braille Authority of North America Guidelines and Standards for Tactile Graphics 2010, and it's available for free download at brailleauthority.org, which is the website for the Braille Authority, and that will help you to make the decisions about where it is that you want to go. There are also a lot of examples that are in there that will help you to figure that part out. If you have questions about this, please write them in, and we'll deal with them at the end of our presentation. Bryan.
Thanks, Lucia. It's Bryan Gould from NCAM, and I'll just say the description writing portion of the webinar will be very brief, but there's 2 full hours on description writing on the Diagram Center website. So if you've determined that an image does need an image description or an alt text or a long description, the description author should ask 3 questions to start off. Why is the image there? Who is the intended audience? And if there's no description, what will the viewer miss? And answering these questions will help you to write effective and efficient description. And I can't advance a slide. There we go. But before you can even write a description, it's necessary to determine what is accessible and what is an image. Really, there's sort of 4 questions. What is text? And we're talking about when you look at the page, what is text? Is the text even accessible? Is it navigable? And then what is an image? And let's look at the page where that heart and lungs diagram came from. and we'll see there's 3 parts to this page. And I won't get into specifics because everybody's production process is different, and you receive your materials in different formats. So you could be working in a digital talking book format, in an HTML website format, with a PDF, with a Word document, and that would be a whole webinar in and of itself. But we'll just ask the questions, or at least formulate the questions that you need to ask, which is, what's on this page? We have the main text, which is the text on the right, under the heading Circulatory and Respiratory Systems. And then in the upper left, we have a totally separate box of text that says Science Link activity changes in pressure. And you need to make sure that if someone's reading this with a screen reader, the text in that box isn't going to be interlinked or intermingled with the text on the right, which can happen depending on how it's coded up. And then on the bottom, we have the systems in sync, the heart and lungs, and what we think part of which is an image. And I'll go to the next slide. So here we've cut out just that little section of the page, and you have to determine, we have the title info, systems in sync, and then you have these 6 great labels, which give you tons of information. Well, is that just text that's actually art in the image, or is it actual text that a screen reader can navigate? And if it is text that a screen reader can navigate, has it been coded correctly so that it reads in order 1, 2, 3, 4, 5, 6? And is it somehow linked with the image and put in the right place in the reading order so that it's not somehow intermingled with, and I'll go back, with the main text? So navigation of text and determining what's actually available to the screen reader before you start describing an image is vital. In this case, the text is readable and navigable, and so you only have to deal with the actual picture of the heart and lungs here. And Lucia's told us that this is a great candidate for a tactile diagram, so the description or the alt text that would be attached to this would be very brief. And I can read out what we've written here. A diagram shows the circulation of oxygen-rich and oxygen-poor blood through the heart and lungs. Now let's go to another image. I've separated them here. We'll look at them one at a time. That's a good candidate for description. Luckily, we have research-based guidelines to help us in our description writing. You can simply Google STEM description guidelines, and there's lots of information there. You can also find these as part of the Diagram Center website. And I'll boil those down to about 10 words. Be brief. Focus on data and not extraneous visual elements. Be sure that your descriptions are written in a clear way, because someone is relying on the words you're writing because either they can't see or can't access the image. Organize your description in a drill-down method, meaning go from the most general information down to more and more specific and down to providing data at the end. And then if you are using HTML, use table and list format and MathML when you can. And I'll show you examples of both of those. So here we have these stopwatches, and they show different types of crime, and each stopwatch has a different colored base, and some of them have a real thick arrow for a timer, some of them have a very narrow arm for a timer, and none of that's important. We need to be brief, focus on data, and really the most vital information here is a type of crime and its frequency. So I've shown in this first stopwatch, get rid of the stopwatch completely, don't even think about it. You have a crime and a frequency, and that's the information that's important to get across in the description. You can write this as prose if you are limited to just using an alt text, and it would sound something like this. Recorded rate of violent crimes and property crimes, aggravated assault every 37 seconds, robbery every 1.2 minutes, so on and so forth. A better solution would be to provide it marked up as a list because it provides superior navigation for someone using a screen reader. Say they needed to quickly find the frequency of burglary, as opposed to having the screen reader read through this long paragraph, or it's actually one big long sentence with lots of commas. They could simply tab down or arrow down and hear burglary and get that information more quickly. A more complex, excuse me, one second. A slightly more complex graphic is this line graph or line chart. There are not too many extraneous visual elements, maybe the colors of the lines, which aren't very important. And there's one thing to notice, or that you do notice when you look at this immediately, and this is sort of a rule of thumb with description. If you can look at a graphic or an image and you notice something in a glance, it should be provided in your description summary or summary description of the image. And right here, we don't even have to know what it's measuring. All we know is that everything that this graph is measuring went up and then went down pretty consistently across the four. So we need to put that information into our summary. So again, this can be written as prose. This would be a longer description. It has a title, Recorded Rate of Property Crimes, and then what is the image? It's a line chart or a line graph. It shows the recorded rate of property crimes 1960 to 2007, including larceny, theft, burglary, and motor vehicle theft. And then we have our summary. All property crimes increased significantly from 1960 and peaked in the early 1980s. Property crimes fell and rose again over the next decade. Since the late 1980s to 2007, property crime has been on a steady decline, though still higher than in 1960. The following data are approximate, with the year followed by the crime rate. So it has a lot of information in there, and you need to provide the specific data points, or many of them anyway, in case the student or the reader needs to have some of that specific information. That's what's provided in the second paragraph. You'll notice the drill down method. At any point, the person who's reading this alternative text can decide that they don't need to know anything more. You have a title, Recorded Rate of Property Crimes. A line chart shows the recorded rate of property crimes 1960 to 2007. Someone could say, okay, that's enough, I don't need to know anything more. Or they could listen to the entire summary, or they could listen to the all of the data. However, if you're working in HTML, it is a far better solution to provide the paragraph of data in a data table. And this is what it would look like here. You'd have the same title, the same summary, and then a much more navigable, user-friendly data table where someone could, for example, again, find the burglary information immediately and then move year to year, or find all the year information and do a comparison that way, as opposed to, again, looking through these lengthy sentences of numbers and numbers and numbers. Much better to put it in a format such as a data table. Of course, a data table to a screen reader doesn't look like the image on the left. It looks like the code on the right. And my colleague Geoff Freed is going to give some examples of how a screen reader actually copes with this and what it sounds like to the end user.
Thanks, Bryan. Hi, everybody. This is Geoff Freed from WGBH. I work with Bryan Gould at NCAM. Now that we've heard Lucia talk about tactile graphics and how they can be useful, and Bryan has talked about image descriptions and how to write them, and what to describe and perhaps what not to describe, I'm going to give you a quick demonstration of how people who use assistive technology like screen readers or standalone digital talking book readers actually access images by description and what that might sound like using a couple different kinds of assistive technology. Before I show you these things, though, I just want to talk for a second about image descriptions and how they can be integrated into various formats. you can use image descriptions like what Bryan was just demonstrating in a variety of digital publications, HTML documents, PDFs, ebooks, digital talking books, even Word documents. If you use OpenOffice, you can include image descriptions there as well. And you can integrate or implement these descriptions through a variety of methods. In HTML, the alt attribute, I'm sure many of you know about that, the long desk attribute as well. In digital talking books, there's an element called prod note. In ARIA, a specification from the W3C, there is a property called described by, among many others, that can be used to link an image to a text description. You can make descriptions visible in a number of ways. You can make them invisible so that only people with assistive technology might see them. One thing to keep in mind, though, when you're integrating descriptions into digital formats is that not all of the methods that I just mentioned work in all formats. For example, a long description delivered by the long desk attribute works in HTML. It doesn't work in PDF. PDF would take a different description method or description format, which we'll see in just a minute. Alt text tends to work in just about any document. Sometimes the way that you insert it into the document is different from the way you might insert it into a different document. And in addition, another consideration, and this is important in terms of what Bryan just talked about, some image descriptions are best presented as prose, and some are best presented as data tables or lists of information. But not all methods of delivering description permit markup. So, for example, alt text, that's a good one. That just takes plain text. You can only type plain text into the alt attribute. The long desk attribute points to another HTML document, and an HTML document can take any kind of markup. So that's a very useful way of delivering descriptions in formats like data tables or lists. However, that useful markup may not be able to be put into a digital talking book and its way of delivering an image description, say through a prod note. So the way that you write and deliver the description is largely dependent on the target format. And if you have a number of target formats, you may find yourself taking the same description and massaging it into different formats for each of these targets. Next, here we go. All right, so having said that, let's take a quick look at some technology. Let me just set something up here. All right, we're going to look at a one-page book, we'll call it a book, that is going to show you an image, that line graph that Bryan was just showing you actually, with a little bit of text, just to put everything in context. We're going to look at this one-page book in three formats, in HTML, in PDF, and as a digital talking book, also known as a DTB. And we're going to do it in the reverse order of what you see on the screen. So we're going to start with HTML. And I need to share my desktop, so hang on just a second. There we go. Okay, let's start here. All right. What we see on the screen is a couple lines of text, and we see the line graph that Bryan talked about a minute ago. And actually, before I show you what this sounds like with a described image, I want to show you what it sounds like without a described image, so that you'll know what somebody using a screen reader runs into when you do not supply a description with an image. I'm going to be using a screen reader called JAWS. For those of you unfamiliar with screen readers, here's a brief primer. Screen readers read text. They only read text. They cannot describe an image automatically. A human has to write a description that a screen reader will read to the user. If you don't provide a description, you get something like what you're about to hear.
Wrapping.
Here we go.
Heading level 1 recorded rate of property crimes. The graph below shows property crime trends from 1960 to 2008.
Okay. The screen reader read 2 lines of text, and then it stopped. What we see on the screen is an image, but the screen reader effectively does not see that image, and so there's nothing for it to read, so it stops as if it's reached the end of the page. This is what happens in just about any document that you might supply without a description. Let me show you another one. I mentioned a minute ago a digital talking book. We're going to take a look at a digital talking book using a reader on an iPad called Read2Go from Bookshare, our friends at Bookshare. Digital talking books are written in an XML format that delivers text. It can deliver pictures. It can deliver sound as well, synchronized audio. DTB readers will come with their own text-to-speech engines, or they can be used with assistive technology like screen readers. It's another format for delivering accessible books or textbooks. So I'm going to open this DTB.
Recorded rate of violent crimes.
And I'm going to press...
Book detail.
Stop talking. I'm going to press the read button.
A penning book.
Okay, and now we see on the screen that same one-page book. And as Read2Go reads out loud, you will see a yellow box moving on the screen that shows you exactly what it's reading. And this is what it sounds like with an undescribed image.
Recorded rate of property crimes. The graph below shows property claim trends from 1960 to 2008. End of title.
Pretty much the same thing. It reads the text, it skips over the image because there's no description, and it says end of title. That's the end of the book. So for all intents and purposes, this image doesn't exist. Now, let's go back to the HTML example and listen to what this page sounds like with an image description. Let me just
Alt tab, Mozilla Fire.
Okay, so once again, using JAWS, I'm using Firefox as my browser. Here's the same book with image description information. After JAWS reads this page, I'll talk for just a minute about what it just did.
Recorded rate.
Here we go.
Heading level 1, recorded rate of property crimes. The graph below shows property crime trends from 1960 to 2008. Graphic A-line chart shows the recorded rate of property crimes 1960 to 2007, including larceny, theft, burglary, and motor vehicle theft. Result plus enter for long description.
Okay, so what JAWS did, and I realize that the screen reader might be reading a little too fast for some of you, but I don't want to slow it down too much. It takes a long time. It sounds a little drunk, and I wanted you to experience a bit of what it's like for somebody who uses a screen reader. People who use screen readers on a regular basis set them to read twice as fast as what you hear now. What JAWS did is it read the first line of text, it read the second line of text, and then it read alt text that has been supplied with the line graph that I'm hovering with the pointer right now. So in the code, there is alt text that reflects whatever it was that JAWS read, and then at the end of the description, it said, has long desk. Press enter. What that means is that the author has provided a long description using the long desk attribute, and the screen reader user will hear, has long desk. Press enter, or press enter for long desk. And if I do that, if I do that,
enter, long description,
what I now see on the screen is the description for that image. On the screen, we see a heading, we see a paragraph summary, which is the summary that Bryan showed you in his slides, and then we see a data table. And this is the data table that Bryan showed you as well. And in a line graph, as he said, sometimes the best way to present that data is through a data table. And so somebody who opens this long description with a screen reader will now hear this.
Long description. Recorded rate of property crimes. Heading level 1. Recorded rate of property crimes. Image description. A-line chart shows the recorded rate of property crimes 1960 to 2007, including larceny, theft, burglary, and motor vehicle theft. All property crimes increased significantly from 1960 and peaked in the early 1980s. Property crime fell and rose again over the next decade. Since the late 1980s to 2007, property crime has been on a steady decline, though still higher than in 1960. The following table shows approximate data with the year followed by the crime rate. Table with width.
Okay. So JAWS read that paragraph, and then there's a table, and somebody with a screen reader can very easily navigate into this table. Unfortunately, there's no visual focus, but I will show you with the pointer what JAWS is reading.
1960, column 2.
JAWS is reading that in column 2, there is the date 1960, and using special key commands in a screen reader, I can move from cell to cell and hear the information in the cell as well as the header information, which is the bold information in the top row and the bold text in the left column. So right now, JAWS is reading 1960. If I go down, I hear this.
All property crimes, 1,800, row 2.
So JAWS told me that in 1960, all property crimes were 1,800. If I go down again.
Larceny theft, 1,000, row 3.
Larceny theft was 1,000, and I think to myself, what was larceny theft like in 1970? I move to the right.
1970, 2,200, column 3.
So, as we illustrated earlier, it's pretty easy for somebody with a screen reader to get through a data table and get at the precise information that they want.
Alt tab, crime notice, alt tab.
Quiet, please. These things get out of hand. I want to show you a PDF with the same information and what it does when it runs into a description. When it runs into an image with a description. So I'm going to have JAWS read this page now.
Heading level 1 crime rates, heading level 2 recorded rate of property crimes. The graph below shows property crime trends from 1960 to 2008.
Hello?
No graphics.
No graphics.
No graphics.
Hang on, this is unusual. Let's do this again.
Graphic the top, crime rates, heading level 2 or no graphics.
Well, here you see the fickle nature of screen readers, because suddenly JAWS thinks that there's no graphic on this page, when in fact there is a graphic with a description. And the reason I know that there's a description with this graphic is that if I hover the pointer over the graphic, you see the description pop up on the screen. So let me describe it to you rather than run out of time trying to get JAWS to do this. What I've included as a description on this graphic is a paragraph of text summarizing the information, and then following that, a paragraph of text with the actual crime data. So all property crime in 1960 was 1,800, 1970, 3,500, 1980, 5,500, and so on. JAWS would read this text if it were in the mood to read the text. For whatever reason, it's not. But the point I want to make here is that unlike HTML, when you supply a description in PDF, you cannot use markup. So I can't supply this as a hidden description with a data table. I can only provide it as prose. That's a limitation of PDF. If I wanted to provide this description as a data table, I'd have to put it on the page, or I'd have to put it on a different page. Give it a summary or a table caption, and then someone with a screen reader could read it in the PDF just like they can in HTML. Okay, finally, let me show you this same information in our DTV reader.
Bookshelf. Recorded rate of violent crimes.
Okay, so this is...
Book detail.
Stop it. This is Read to Go, reading...
A penning book.
When you work a lot with text-to-speech technology, you find that some text-to-speech technology pronounces words differently than others. What Read to Go was saying was opening book, when it really needs to say, I think, opening book. What I'm going to do now is tell Read to Go to read this page, and again, you'll be able to see what it's reading with the yellow box as it moves. And I'd just like to point out on the screen, I'm hovering over now, the description for this image is made visible in Read to Go. That's a feature, it's a nice feature that puts the description on the screen. And here's what it sounds like.
Recorded rate of property crimes. The graph below shows property crime trends from 1960 to 2008. Image description, diagram XML. A line chart shows the recorded rate of property crimes 1960 to 2007, including larceny theft, burglary, and motor vehicle theft. All property crimes increased significantly from 1960 and peaked in the early 1980s. Property crimes fell, then rose again over the next decade. Since the late 1980s to 2007, property crime has been on a steady decline, though still higher than in 1960. The following data are approximate, with the year...
Okay, I'll stop it there. So again, Read to Go read the text above the image. It announced that there's an image description because that information is placed on the screen, and then it read the description itself. And like the description in the PDF version. This description is provided basically as prose. While you can provide marked up descriptions in the digital talking book format, this particular DTB reader does not know what to do with that markup in a description, and so it will either take the markup and turn it into a block of text as best it can, or for a more reliable delivery to the user, you would just want to provide it as prose. But again, there are some DTB readers that will provide support for markup in image descriptions. So that is a quick demonstration of what image descriptions sound like to people using various types of assistive technology. Let me go back to the slides here. I just have a couple more things to add to that. If you're new to assistive technology, what you just saw and what you just heard might be a little confusing. I'll tell you that you're not alone. If you're learning about assistive technology, the learning curve is kind of steep, and screen readers can be difficult to learn how to use, but they can be very powerful and extremely useful when given materials that have been marked up to be accessible. A quick note about offering applications for providing, creating, delivering accessible images. When it comes to things like HTML or PDF, there are a number of authoring tools that you can use to integrate descriptions with images. Word will do that for you. InDesign, if you use InDesign for PDFs. OpenOffice will do the same thing. HTML editors all support the inclusion of the alt attribute. Some of them will ding you if you have an image without the alt attribute. They'll let you know that you need to put one in. Longdesk is also supported by many authoring tools. Some you have to author by hand, however. DTB authoring tools, there are a number on the market. A couple of popular ones are Dolphin Publisher from Dolphin Access in the UK, and another one from the DAISY Consortium is called Toby, which is what I used to create the DTB that I showed you here. Both of them support image descriptions in different ways. You can also use OpenOffice to create DTBs from essentially Word documents. You can also use a tool from Bookshare called Poet, which is a free online tool for adding image descriptions to DTBs. You can learn more about Poet by visiting the diagram website, in fact. Okay. And then finally, if you'd like to know more about devices that support image descriptions in all the various ways, I suggest you take a look at the Diagram website, which is diagramcenter, one word, .org, diagramcenter.org. We have a number of good resources there, including the Diagram Product Matrices, which is a series of tables or charts showing you what hardware and software readers are available for reading DTBs, for reading ebooks, and what image support is like in these various devices and what is available. So you can take a look at that. And with that, I'll turn things back over to Julie, I believe.
Thank you so much, Geoff, and thank you also to Lucia and Bryan for a terrific presentation. And before we conclude, I want to do the Q&A, and we'll have some time after the Q&A for just some concluding remarks from Bryan and myself, some more resources that you can look forward to, especially if you're going to be going to some conferences coming up. So I'm going to work backwards with the Q&A because, Geoff, we just heard from you, and we had one comment and one question. One comment, thank you for that demonstration. It's difficult to hear the work I do with PDFs since I don't have a screen reader. I just have to go on text that's in there under the image. So there's a comment of appreciation for that. And then a question. You used Read to Go for iOS, but iPad has VoiceOver. Does this mean that VoiceOver is not guaranteed to read alt text?
It depends. VoiceOver, for those of you who don't know what VoiceOver is the screen reader that is built into all iOS and OS X devices. So if you have an iPhone or an iPad or an iPod Touch or an iPod or an Apple TV or an iMac or any Mac laptop, you have a screen reader already in your computer, and you may not even know it. That's called VoiceOver. And VoiceOver on the iPad or on any iOS device will, in fact, read alt text in web pages. The way that VoiceOver works with other applications besides web browsers or email clients is largely dependent on how the app itself was coded, how it was authored. Apple offers a lot of information, a lot of resources for creating accessible iOS apps. The reason that Read2Go has its own text-to-speech engine is because that's how many DTB readers work, is that they come basically as complete book reading packages. So a DTB reader can take a book in the DTB format and read from the XML and use its own text-to-speech engine to convey all the information. Some DTB readers will also play back audio that has been supplied with the book. So instead of doing text-to-speech, it will simply read audio that comes with the book. And some DTB readers can be used by VoiceOver or other screen readers, and some cannot. Julie, could I just address the comment from Margaret Driscoll about PDFs and screen readers really quickly?
Absolutely.
Yeah. If you don't have a screen reader and you need to verify accessibility of materials, or you want to verify their accessibility, you have a number of choices. If you're a Windows user, you can have a free screen reader called NVDA, Non-Visual Desktop Access. That's what NVDA stands for. If you just Google NVDA, you'll find it. It's a free download, and NVDA is an open source screen reader, and a lot of very smart people are working to develop NVDA, and it's a nice screen reader. It's almost as sophisticated as JAWS, which is probably the most popular screen reader that is being used by Windows users. I showed you JAWS, but NVDA works basically the same way as JAWS. If something works well with NVDA, there's a really good chance that it will work well with JAWS as well. But you should also download yourself a demo copy of JAWS. If you go to freedomscientific.com, you can download a demo copy that will work for 45 minutes, reboot your computer, get another 45 minutes, or you can buy JAWS. License is about $1,000. If you're a Mac user, you've got VoiceOver. VoiceOver it has some limitations that don't make it quite so powerful as the Windows screen readers I just mentioned, but it's still a very sophisticated screen reader and being improved all the time by people at Apple. You should also check your materials with that. So you do have options. One thing I'd like to point out is that the Read Out Loud feature that comes with Adobe Acrobat and Adobe Reader is not a screen reader and should really not be used to test the accessibility of a book. It reads the text, but it doesn't provide any navigation support like a real screen reader does, and so you can't really use that to judge accessibility. Thank you.
Thank you, Geoff. So let's switch. We had a few questions for Bryan. And Bryan, these questions came in at about slide 23 or so. And so just to give you a heads up, we might want to go back there. One question we had is more and more we integrate annotations into figures to guide sighted readers through the figure without having to move back and forth between the figure and the caption. That seems problematic in terms of accessibility. Can you give us some advice about this?
Well, thanks for your question, Catherine. Of course, without actually seeing an example, it's difficult to give any specific advice. But for annotations, we have been, and maybe Geoff can talk a little bit more about this, but using some of the features in ARIA when we're working in HTML. Otherwise, if you're simply dealing with an annotated figure, then, again, like the beginning of my presentation, you have to determine what's text and what's an image, and then sometimes it's an awfully long image description to describe both the diagram of the image itself and include the annotations to present the information in a way that is comparable to the visual experience, or the way it's supposed to be experienced visually. So not a simple answer for that one.
Julie, can I add to that? It's Geoff?
Sure.
Yeah. In addition to what Bryan said about text being a part of an image and deciding what to describe and what not, if the text is not part of the image, in other words, if it's acting like a caption in a box with an image, there's new markup in HTML5 that can help associate explicitly a text caption with an image. There are two elements that you can take advantage of now. One is called figure, which is what you would use to contain the picture, and one is called fig caption, F-I-G caption, which is what you would use to contain the caption, the text, and associate that with the image. In some cases, the caption might contain enough of a description that you don't need to add a further description. But in some cases it may not. But in either case, you can explicitly associate that caption with the image. But in all cases, you'd also want to provide alt text, at least.
Okay, thank you, Geoff. So we had another question, and it referred to a particular slide, and I think it was slide 23, the one that I'm on, and the question was, wouldn't you want to put a semicolon after the crime rate number in this example? Does this ring any bells for you? Yes.
Yes, and actually Geoff did that when he went and put it into his slides and actually ran it through the screen reader, so that was my error. So that's why, if you do a long description training, you find out that all of your descriptions should be edited by someone else in case you make an error like that. So okay. Good catch.
And a final question. On the recorded rate of, this is for Bryan, on the recorded rate of property crimes, how does the screen reader know to differentiate a year, 1960, from a number, 1800, for example?
Sometimes it does and sometimes it doesn't. Geoff, do you have a better answer than that? I mean, it depends on, sometimes it depends on the screen reader you're using and the setting, and it's also it's the user as well who's going to know what it is they're listening for. That's why you would always set it up, as we did there, saying the year is followed by the rate or the amount. Right.
Yes, all of that is true. Plus, screen readers also deal with information in context. And sometimes, depending on how the date, for example, 1960, is inserted into text, it will be read correctly, and sometimes it won't. This is, I think you heard me use the word fickle a little while ago when JAWS decided not to behave properly. Screen readers are fickle. They're grumpy, and sometimes they're a little unpredictable. Even though I praise them up and down, they can still misbehave. And sometimes reading dates in context will force putting a date in context properly will force the screen reader to say 1960. And sometimes it'll say 1960 as well. However, if you have a number like 1800, if you write it 1,800, any screen reader will pronounce that as 1,800, or I think VoiceOver will say 1,800. So context really counts here.
And again, that's another good reason when you can to put information in a data table to separate out those numbers from the years, or the amounts from the years.
Thank you, Bryan. Well, that concludes the questions that came in over chat, and feel free, if there are others that occurred to you or that occur to you later, you can always write to us, and I can get questions to the right people, and the email addresses of the presenters, I believe, are on the first slide of this session, which will be made available to you after the webinar. So I'd like to conclude for just a couple of minutes. First, we'll hear from Bryan Gould about a special opportunity for you publishers who may be on the line.
Yes, as part of our research activities, the Diagram Center is conducting interviews with content producers to better understand the current practices and challenges surrounding image description and access to images in educational books. The purpose of the interviews is to provide the Diagram Center with guidance for additional project activities, including creating free tools like Poet, which was mentioned, and trainings like this webinar. Of course, any reporting and results of these interviews would be anonymous to protect your interests, and we can talk more about that offline. If you're a publisher or a content creator, please contact me for more information and an opportunity to help out the Diagram Center create even better stuff. I'm at Bryan_Gould at WGBH.org. Thanks.
Thank you, Bryan. And if you are looking for even more information, I just wanted to let you know that Diagram will be hosting a couple of panels coming up at CSUN. And for those of you who aren't familiar with CSUN, that's an acronym. It stands for California State University Northridge. Their conference is coming up next month at the end of February, beginning of March in San Diego. And we'll be having a couple of panels there. One with Larry Goldberg, who's Bryan and Geoff's colleague at WGBH NCAM, and George Kirscher of the DAISY Consortium and Betsy Bowman at Benetech will be speaking on a very interesting panel called Born Accessible, Inclusive Publishing. I think they'll be talking about new tools and new standards and accessibility beyond the text for images, charts, math, diagrams, etc. So that will be a good one. At the same conference, there'll be a math panel for those of you interested in accessible math. Dave Schleppenbach from GH, Neil Soyler from Design Science, Ed Summers from SAS, and Ann Bowie from Benetech. We'll discuss emerging technologies intended to improve the accessibility of math educational content, from web-based graphing calculator that produces accessible graphs to tools that help students input algebraic expressions. So if this is an area of interest for you, you won't want to miss that. Diagram, it's not on this slide, but Diagram will also be at Tools of Change in New York City. If any of you attend that, that will be another one with Betsy Bowman and others to talk about issues related to born accessible content. So I want to please, I'm sure you join me in thanking Bryan, Lucia, and Geoff for a really informative demonstration and presentation, and thank you all. There were nearly 100 people registered for this call. I thank you all for taking the time, and we hope to see you at a future webinar. Bye, everybody.